I will share. Okay, I will share the screen. Okay, share the screen. And I have no other, so I have not found the quickly other solution than to type math. So I will type like this. I will type equations and I will provide you my notes afterwards. So I will type like this: x squared is equal, let's say, square root of 5, and it will be transformed into equation on the fly. I haven't found a better solution. Normally I write on my pad, but that's the best solution I've designed in 5 minutes. Okay, so now we will solve the problems that I have posted in the Telegram chat. And my main goal is to practice more and more. So we will solve these problems. If these problems seem very easy to you, that's okay. Just tell me, and I can switch to something more complex. If, on the contrary, I'm going too fast, then don't be shy, don't be afraid, and say, "Oh, we are going too fast. I'm lost 5 minutes ago. Please be gentle," and so on. So any comments are welcome. The unique possibility to save online lectures is to be active, because online lectures are awful by design. There is a great distance between us, and sorry. Okay, so I will start probably with problem 1.2. I will start with problem 1.2. And I will, my main goal is to show you some unexpected techniques to work with this problem. Okay, let's consider the problem 1.2, where Elon throws a fair coin until head appears. And the probability, so the probability P is the probability of head, and let n be the number. Yeah, I can do like this. The number of throws, the total number of throws. Okay, our main goal is to find expected value of n. You understand that to find variance of n, obviously it is sufficient to find expected value of n squared. So we know that variance of n is equal to, maybe you know that it's expected value of n squared minus what? Who remembers? Anyone?
E of n squared, like
yeah, minus expected value of n, but you should square the entire result. Okay, hence to find expected value variance, it is sufficient to find expected value of n squared. Yeah, it is sufficient to find variance. And in the text of the problem, we need also to find expected value of n cubed. Yeah, we need also to find expected value of n cubed. And I will use a technique that was mentioned during the lectures, that there is a very powerful way to find all these expected values at once. Okay, so there is a very interesting way to find all of these expected values, and even further, expected value of n power 4 and so on. It is sufficient. Sufficient to find expected value of the exponent of Tn. It seems strange that instead of powers of n, I will find expected value of some exponent. But let's do this and let's see how we may use the expected value of the exponent to calculate easily all expected values of all the powers we need. Okay, so instead of finding these expected values one by one, I will use the definition of the moment generating function. And using moment generating function, I will quickly find all the expected value, all the expected values I wish. The idea is clear? Yeah, shall we continue? Anyone?
Yes, it's clear.
Okay, so we have a Markov chain here, obviously. The Markov chain is very simple. Either the game continues, either the game stops. Yeah, this Markov chain is very, very simple. We have two states. Let's say state C, and let's say final state F. Yeah, and from or it's better, let's say C continue. We continue the game, and F is the final state. The game ended. So we have basically two states. What is the probability of going from state C to state F? Yeah. If now I throw a coin, yeah, because I weigh head, yeah, hence the probability is just P, that the game will finish in one step. And from state C, I may go to state C with probability 1 minus P, yeah, because the game will continue if I will throw tail, yeah. That's okay. I have two states in this Markov chain. Two states in this Markov chain. These are transition probabilities from C to F and C. And what are the transition probabilities from F to F? And what is the transition probability from F to C? If F is the final state, the game ended, basically. What are these probabilities?
1 and 0.
Yeah, 1 and 0. If the game ends, so we say, oh, we do not, so we may say that it is absorbing state of the Markov chain. It is impossible to continue game if the game ended. Okay, so this probability from the final state F, so that the state, the game continues, and this is a final state, the final state. Okay, this Markov chain is very, very simple. Okay, let's find expected value. It's a little bit difficult for me to draw because I'm not quite fluent in the mermaid diagram syntax. So I can do it, but I need to Google notation. I can do diagrams. Yeah.
Well, you can try to draw with the mouse in the Zoom.
Yes, but it takes time. Yes, I can, but I think for the moment it's yes, I can draw. I can draw like C is here, but it's a little bit awful. Yes, I next time I will, but I will check all the permissions of
No,
Zoom.
I just suggested.
Yeah. I understand, but it's very ugly. So we may go here, but I hate this style of okay. And from state, yeah, basically the diagram is like this. This is state C. We continue, and this is state F. Yes, I can draw with the mouse, but that's very bad. I hope you can draw from these probabilities. Yeah.
Yeah, I just suggested, so maybe it could help a
if it's
lot.
not clear, I will do, but normally when I write with on the pad, it's natural. Okay, let's continue. Let's how I can switch off this drawing. Yeah. Yeah, and it stays here. Oh, I need to remove it somehow. Okay, so we are searching for this expected value of exponent of Tn. So we are searching this expected value. Basically, that's a function of t. That's g of t, or let's call m of t. Yeah, m of t. That's moment generating function. So the letter normally used is m, moment generating function. So we're searching for a function, not for one value, but for a function of t. Okay, let's do this. We will find two functions. One function for the state f, and one function for the state c. So basically, we will find two functions. One function that calculates this value, assuming that we start at c, and the other one calculates the same value, assuming that we start at f. Okay, so we will find mf of t, that is obvious, and mc of t. So once again, what are these values? How I may remove this drawing, annotate, eraser. Okay, this. What is the function m of t? So let's start with the easiest one. If we start at f, at the final node, how many steps we do need to reach? If we start at f, how many steps do we need to reach f? If we start already
0.
Yeah, if we start already at f, then we need n equal to 0 moves to reach f. Okay, so hence the first function is done. Mf of t is expected value of exponent of tn, but n is equal to 0, so it's expected value of exponent of 0. So it's expected value of 1, and expected value of 1 is just 1. Okay, the first function is found. Let's find the second function. Any questions here? If we start at the final node, we need 0 moves to reach final node. Hence, n is equal to 0. Tn is 0. Exponent of Tn is 1. Expected value of 1 is 1. Any questions?
There is a question in the chat.
In which chat? Zoom chat or Telegram chat?
Zoom chat.
Okay. I don't like to. Okay, yeah, I have opened it. What is m? M is a function we are searching for. M of t is a function that will help us to find this function m of t. It is here.
Recording in progress.
This function m of t, we will use this function to calculate expected value. We will use the function m of t to calculate expected value of n, expected value of n squared, expected value of n cube, and so on. And I consider two versions of this function. The first one, the simplest one, assumes that we start at final node. The second one, the right one, the function actually we need to find assumes that we start at the node C. Okay? Daniel, that's okay?
Yes, thank you very much.
Okay. We have more guests. We are happy. Okay, let's calculate the second one. And we will use first step analysis. Let's consider what happens after one move. Okay, we calculate MC of T. So now we are starting at the node C. We are starting at the node C, and we calculate this expected value. Let's think a little bit. What may happen after one move? After one move, with probability P, we can go to, we can spend one step and arrive at the final node. So with probability P, we will, so let's write in text with probability P, we will make one move, and arrive at F, or with probability 1 minus P, we will make one move and arrive back in C. Yeah, there are basically two probabilities and arrive at C. Yeah, so basically there are two probabilities, two opportunities, two subcases we need to think about. What will happen after one move? After one move, we may go back to C with probability 1 minus P, and with probability P, we will arrive at the final node, and N will be equal to 1. Okay, so we have a very simple equation. With probability P, the N will be equal to 1. Okay, but if N is equal to 1, then our exponent of NT is equal to T times 1. Yeah? With probability P, we arrive at the final node, N is equal to 1. If N is equal to 1, then exponent of T N is equal to exponent of T, and I have simplified the first expression. Now let's go to the second expression. Any questions about the first one? What will happen if we arrive at F using just one step? Oh, you're lost. Everyone is quiet. Okay. I'm starting at the node C. With probability P, I will arrive at the final node in one move, and the game ends. N is equal to 1, game ends. And with probability 1 minus P, I will go back in the node C. That's clear. Any questions?
No, I guess
No questions.
Okay. The case with probability P just gives me N equal to 1, and I plug in N equal to 1 into my exponent. Exponent of T times 1 is exponent of T. What will happen? It's very interesting. What will happen if I go back into original node? If I go back into original node, I will spend one step for nothing. So I just spend time, I spend one step, and I start the game in U. If I go back into initial node, I will, let's say, lose one move, and I start the game in U. So how to write it in mathematical form? So it is expected value of what? Of exponent T. And here is very interesting idea. I just write N plus 1. Let's see why. What is N? N is a random variable. It's a random number of moves that is necessary to go from state C, from starting state C, to final state F. If I go back from state C to state C, then one move is gone. One move, I've just spent my time, so I add one. But the game starts anew, and once again, before me, I have a random number n of moves to finish the game. Yeah, so that's why I have t multiplied by n plus 1, n moves ahead of me, and 1 moves behind me. I have done 1 move, and I haven't changed my position. Any questions?
Well, I just feel a bit
No.
lost.
Okay, let's redo. The first equation is clear, mc of t. So when you start from the node C, you either finish the game in 1 move, either with probability 1 minus p, you go back to the node C. That's okay, the first equation.
Yeah.
Are you sure? So the first idea. We start at C. We start at C. And if we start
Yeah.
at C, we have 2 possibilities. With probability P, we will move and arrive at F, or with probability 1 minus P, we make 1 move and arrive at C. Okay?
I see. I got it. I think. Yeah.
Okay, so the second
I got it.
equation. Yeah? If we make one move and arrive at F, then n is equal to 1, because n is the number of steps we do to finish the game. Okay, so I just plug in 1 in the expected value of the exponent. Now, equation number 3. So that's the hardest part. What should I write here? I should write expected value of exponent, and what I should realize here. I should realize here the idea that I've spent 1 move. So 1 move is gone. I have spent time. 1 move is gone. But I'm at the starting position. And ahead of me is my new game. And my new game is exactly the same as the initial game. So I have done 1 move, and the situation is exactly the same as the initial situation. So I write 1 plus n, or n plus 1 times t. Yeah. Why? Once again, because 1 move is done and random number of moves n ahead of me. Okay, that's fine.
And n is the number of moves that is a random variable?
Yeah, n is a random variable. That's the number of moves that I need to go from C to F in this case. N is a random variable, yeah. Okay. Now, let's solve this. Because exponent, I may write here exponent of t times exponent of n. Yeah, I may write, no, that's bad. I need more brackets in my formula. So exponent t times 1 plus n, because when you exponentiate a sum, that's just the product exponent of t times exponent of 1. So I may take out exponent of t out of the expected value. And finally, I will get equation number 5 that is easy to solve. And I will give you the chance to solve it. Equation number, yeah, I have a little bit more brackets than needed. Okay. So I have, sorry, Tn here and Tn there. But expected value of the exponent is called m. And I have exponent of t, mc of t, and we are done. That's basically an equation. I hope that everyone can solve equation number 6. So just let's recap. We are searching for the function mc of t. And our strategy is to build an equation for mc of t. How we are doing this? We see that after the first move, there are 2 possibilities. The first possibility is very simple, n is just equal to 1, the game ends. And the second possibility, we just remark that after the first move, the situation is exactly the same as initial situation. So the number of moves once again is random, n, but we should augment it by 1 because 1 move is in our past. Okay, any questions? The equation 6 is clear, or there are questions here because that's the most complicated step.
Sorry, I kind of lost. What is t variable?
What is t variable? What is t variable? T variable is
Well,
just I will try to answer, and then we need to find so our goal initial is to calculate a lot of expected value of n, expected value of n squared, expected value of n cubed. Instead of these particular expected values, we are trying to calculate one function that is a technical object that will help us to calculate all these expected values. So for the moment, t is just a parameter. T is just a parameter that will help us to find all the expected values.
So we are trying to derive t.
No, just probably it's better to see what will happen, how we will use t, okay? So just bear with me and you will see why it was a good idea to introduce t in our game. So we will use this function. So for example, for example, you have a parabola function, quadratic function, and you can encode in this function roots of the polynomial. And so you can say, instead of just writing 2 numbers in your copybook, you can write a quadratic function, and that quadratic function just encodes 2 real numbers. Yeah, you can think that a quadratic function encodes 2 real numbers. That's okay? So, so you should write a password, yeah, but instead of writing 2 numbers, 2 pin codes, you just write a quadratic function that encodes these 2 numbers in your pin code. And we will use this m of t in the same way. M of t per se is useless. We will not use it. But with m of t, we will calculate expected value of n, expected value of n squared, variance, and so on, more useful objects. That's okay? That's better. So that's a technical object that is very useful to calculate expected values. Like this. Okay?
Okay.
Any more questions? Now, what is the value of m of c? Who has calculated m of c? who has solved this simple equation? So you just express that with simple algebra. I hope you can do so. Anyone solve equation number 6?
Well,
and
can
the
you repeat, please?
Can you solve the equation number 6 and find m of t, the function?
M of C, you mean, yeah?
M of t, mc of t, or m of t. So what are these functions? So that's a simple algebra.
Well, this is just a moment.
Yeah,
There is an answer in the chat, if you can see it.
yeah. Yeah. Thank you, Roman. Okay, that's p exponent PET divided by 1 minus P ET. Yeah. Or we may write like this. Better to write like fraction E of t. Oh no, that's too small. Okay. Oh, I think it is better to. Oh, okay. It's P of t divided by 1 minus P multiplied by exponent of t. Okay, what is the use of this function? And hence that's important moment. Let's recap. Yeah.
It should be 1, I think, because if we try to no, I'm wrong. I think, sorry.
I think that's like this, because my answer is the same as Roman's answer, so I think we are either both correct, either both wrong, but the probability that we are correct is high.
No, I just miscalculated, sorry. Nothing.
Okay, what is the use of this function? Once again, what was the meaning of this function? Expected value of the exponent of Tn, yeah? So that was the meaning of this function. That's what the meaning of this function. And now how we can calculate all expected values. So if I'd like to calculate expected value of n, what should I do? If you recall the end of the lecture, it is sufficient to take the derivative of this function at 0. Let's see why. Okay, if I take mc prime at 0, what will happen? If I just take the first derivative of this function at the point 0, what will happen? Let's do this step by step. So if I take the derivative, I will get expected value of n exponent of Tn. So that's just why it is so. I will just write the answer. No, factorial is the wrong idea. So m prime c of t. So the from one point of view, it is just expected value of t exponent of Tn. Sorry, of n, I think, with respect to t. So that's the derivative. If I take derivative with respect to t, n will appear inside expected value before exponent, if I just take the derivative. If I take the second derivative, another n will appear. If I take the third derivative, another n will appear. Yeah. And if I plug in t equal to 0 in these three expressions, I will obtain expected value of n, expected value of n squared, and expected value of n cubed. Yeah. So if I plug in 0 instead of t in these three expressions, Tn will be equal to 0, exponent of Tn will be equal to 1. So this will be expected value of n. That will be transformed into expected value of n squared. If I calculate the second derivative at 0, and if I calculate the third derivative at 0, I will get expected value of n cubed. Is it clear?
More or
Yeah, it's
less.
just we calculate for general cases and then just put instead of t the 0 in each of.
Yeah. I hope I will not spend your time. I hope you can take derivative of this function. So what do you need to do to finish this exercise? I leave it to you. You just need to take, because I think taking derivatives you can just use SIMPy in Python, or you can if computer is unavailable, you can do this by hand, but taking derivatives is a boring exercise. So how to take derivatives? I believe that you can take derivatives. Probably it's boring, but I hope you know how to take a derivative of a fraction, how to take derivative of exponent of t, that's exponent of t. So that's just a simple exercise. But maybe I will take the first one. The first one in this case, it's a fraction. We square the denominator, yeah. But I hope you can do this. I hope I'm a little bit lazy. Okay, you square the denominator. I hope you remember the formula how to take derivatives. That's okay? Yeah, everyone can finish. I understand that maybe it's boring, but it's a way to. It's one of the way to solve this exercise. That's okay?
Well, I think it's too late to ask this question, but I
No.
think I'm not sure how we get one move to f. How we got to that one move to f, for example, it is e in the power of t.
N is a random variable. What is n? I have not written this. No, n is a number of throws we need to make to go to final state. We consider starting from the state C. So if you start from the state C and at the first row, you finish the game. What is the value of n in this case? If you finish the game in one throw, what is the value of n?
If in one throw, then n equals 0.
No, one. Not n is a number of throws.
Yeah.
If you
Yeah,
finish
yeah,
the
yeah.
game in one throw,
Yeah,
then n
yeah,
is a number in
yeah,
total.
yeah.
Maybe I should add the total number.
Just
Okay.
yeah, in
So
total
in
is
this
1,
game,
yeah.
n is equal to 1. Hence, Tn is equal to t. Hence, exponent of Tn is equal to exponent of t times 1. And the expected value of also is exponent t times 1 times p. Yeah. We multiply probability by the value of random variable. Yeah. Okay.
So basically, because we know that m of t, I see, yes, that because we have m of t equals to e exponential of tn, We just say that it is if in one throw, then we have E and T.
Yeah.
Okay, but why we say then the M of T equals to E to the expectation of E in the power Tn? It's just like we want to find this M of T, but why we claim like that it is equal to this?
No.
To
We
this
calculate
expectation.
expected value. How you calculate expected value? You multiply probability P by the value. If n is equal to 1, then what is the value of n? 1. What is the value of exponent Tn? You multiply probability by the value of the random variable. Yeah?
Yeah.
Yeah, you're right. I can do this to make bigger. Yeah, Daniel, I forgot. Yeah, that's bigger. Yeah, can do double quotes to make display. Oops, make display equations bigger. Yeah, all right. Okay. And, okay, I will not take derivatives because I'm lazy. I can take derivatives, but I will show you how to do this in SimPy, and you can use computers for simulations in your home assignments. So you can do simulations, or you can use computers for tricky derivatives. But I will mention this in every home assignments, whether you should complete the exercise by hand or you are free to use computers. Okay, so let's move on. We have, we have 20 minutes. Yeah, let's solve one more tough exercise. I hope you can take 3. Yeah, I hope. Okay, let's move on. Let's consider now exercise number, which one is very interesting. Let's consider the exercise number 1.4. I hope that's even more interesting. Okay. We throw a dice unbounded number of times. If it shows 1, 2, and 3, then the corresponding sum is added into the pot. So initially pot is empty. Initially the pot is empty. There are no money in the no money in the pot initially. If the dice shows 1, 2, or 3, the corresponding sum is added into the pot. Okay, if the dice shows 4 and 5, you take the pot with money, probably with money, and the game ends. The game ends. If the dice shows 6, you're unhappy because you lose the game, and you get nothing. Get nothing, and the game ends. So there are many questions. The first one may be very easy. The first one: what is the probability that the game eventually ends by 6? What is the probability that the game, that's easy, I think, eventually ends by 6. I hope this question is very easy. How many possible final dice values do we have? What is the last value that may be on dice? Well, can the game end by dice showing 1? Can the game end by dice showing 6? Can the game end by dice showing 4? What are the possible terminal values shown on the dice? Anyone? Do you understand the rules of the game?
Yeah, I just, for example, finished only understanding now. Yeah.
Maybe 1, but I'm not sure.
It's 1/3.
Yeah. There are 3 possible final values on the dice. Yeah. You may get 1, 2, 3, 2, 3, 2, 3, 2, 3, and then 6. Oops, and you get nothing. Or you may get 1, 2, 3, 5, and you win 1 plus 2 plus 3, the total value in the pot. Or it may be 3, 3, 4, and you win 6, because 3 plus 3 is 6, and 4 is a possible terminal value on the dice. Yeah, that's okay. There are 3 terminal states in this Markov chain. Either you see 4, either you see 5, either you see 6. Obviously, the dice here, it's, I think in the text, it's written that it's a fair dice, and hence that's 1/3. Yeah, by symmetry, we get 1/3. That's okay. Shall we continue? Or any questions?
There are
No questions.
Okay. Let's move on to the point. Let's move on to the point B. Yeah, let's move on to the point B. The point B, I think what is the expected duration? Yeah, I don't remember the question. Yeah, I think, yeah, what is the expected duration? Expected duration of the game. Once again, let n be the number of rows. And because we don't need to calculate the variance, so we will simply use the first step analysis directly to expected value of n. We will not use the moment generating function like in previous example. I feel that it was a little bit hard for you, your first encounter with moment generating function, but don't be afraid, we will come back, and after 3 or 4 classes, you will say, moment generating function, that's the obvious thing. But the first encounter with moment generating function is tough. Don't be scared. Oh, probably you may be scared for now, but it's a quite useful object. Okay, let's all be. Let's calculate expected value of n. Let's denote this expected value of n. I don't know. Let's denote it by small a. So let's denote it by small a. And hence, let's write the first step equation. First step equation. Okay, what is a? With probability 1/2, the game ends after the first step. So with probability 3/6. So there are 4. So if I begin the game, if I throw 4, 5, or 6, the game ends in one step. So with probability 3/6, I will just get one step. With probability 3/6, so if 1, 2, or 3 happens, I will do one move and I will go back to original situation. So the same logic applies. It's expected value of n plus 1. Once again, let's understand this, or maybe I don't need a. Maybe I don't need a here. Yeah, I hope I don't need this a. Okay, first step equation. Expected value of n with probability 3/6, game ends in one move. With probability 3/6, I do one move, I go back in initial situation. I have more money in the pot, but when we speak about expected duration of the game, money in the pot is irrelevant for our expected value. And n is increased by 1. Once again, we have random future, random number of moves n, but augmented by 1 because we have already done first move. That's okay? The equation is clear?
Yes, the question is clear.
Yeah. Okay, the solution is very easy. We just say that expected value of n, let's denote it finally by a. Expected value of n, let's denote it now by a. And hence our equation is a, let's multiply by 6. We have 6a is equal to 3 plus 3a. 3a plus 1. Yeah. If we multiply by 6, we get 6a is 3 plus 3 plus 1, and hence a is equal to, I hope that is 6/3 is 2. Okay, point B solved. Any questions?
I guess no questions.
Okay, and now the hardest one. Now the hardest one. The main question. The main question. Let's denote by f, by not by x. In the random payoff we get. Random payoff we get in this game. And the question is, what is the expected value of x? So n is a number of throws, the random variable, and x is a random payoff. And once again, we will use the first step analysis. We will write first step equation, and we will solve it. It will be linear once again. Okay, let's check what may happen after the first step. Expected value of x.
Can I ask you a question about
Yes.
B?
Yeah.
So yeah, we have mass expectation of n is equal to 3/6 times 1 plus 3/6 times e of n plus 1. But shouldn't it be if of n минус 1? Ну, то есть мы просто расписываем, да, то, что у нас мат ожидания того, что вот мы закончим игру в 5 бросков, равно, ну, вот то, что мы за 1 бросок закончим, плюс то, что мы закончим игру за 6 бросков. Ну, это как будто немного нелогично, либо я просто не понял еще логику.
No, we can end the game in 1 throw, in 2 throws, in 3 throws. I don't get your idea. There may be 256 throws. I don't get why 1 or 6.
No, just I think I meant it like that because we have we have 6 sides of the cube. That is why we have like 6 cases. But it is actually not, because 1, 2, 3 is not counted. It can just happen
In the
endlessly
point
times.
B, we do not care about the. In the point B, we don't care about the value in the pot. We just care about the duration of the game.
I know. I
Okay.
just I think his question is about point A,
Yeah.
the previous one.
No, it's actually
So
about point B.
mm,
Ну, я
Okay,
просто
in
не
point
понимаю,
B,
да,
we
то
are-
есть мы пытаемся мат ожидания n посчитать через мат ожидания n плюс 1.
Да.
Это
Yes.
кажется немного странным.
Yes, but we succeeded. So that was a good strategy. Yeah. We see that the game after the first step is almost similar to initial game. And hence, we build an equation. So that's not, that's a new method. First step analysis is a new method that we will learn in this course. Yes, you're right.
I got it now. I probably just thought for a minute that n is not a random variable, but
N
some
is a
value.
random variable.
Now I understand.
Yeah.
Thank you very much.
So I will add here random. Yeah. Okay, more questions? Or maybe let me finish the equation for expected value of x. Okay, if the dice throws 4, 5, and 6, and it's the beginning of the game, the pot is empty. If the dice shows 4, 5, and 6, I get 0, and the game ends. Yeah. So with probability 3/6, I will get 0. Yeah. So first I consider simple cases. I start the game with empty pot and I throw a die. I pay attention only to the first step. And I compare the resulting game with initial. So I'm building a recurrent equation, honestly speaking. First, I consider simple cases. If I throw 5, 4, 6 in the beginning of the game ends, I get 0. Okay, now let's continue. What will happen if I throw 1? Obviously, this happens with probability 1/6, but what is this value? So the structure of the equation is more or less clear. I have 6 possible cases. All cases are with probability 1/6. 3 cases are very easy. And 3 cases when I add something into the pot. So let's consider them. Okay, for example, if $1 is added into the pot, the game is more favorable to me than the initial game. Yeah, because in initial game, the pot is empty. And if I start with $1 in the pot, I'm more happy. So it should be expected value of x plus something here. If I will throw $2 will be added into the pot. Hence, the game is better for me. I have initial game, but $2 in the pot. And finally, if I will throw 3, the game is more favorable to me because it's like initial game, but something is already in the pot. What should I write instead of question marks?
Maybe 1, 2, and 3.
You're almost right. You're almost right. I will write 1 and leave a question mark here, 2 and a question mark here, and 3 and the question mark there.
Maybe power n. No,
Maybe?
like 1. Maybe 1 in power n, or just like
Not
we
exactly.
don't have the memory. No.
Just imagine 2 games. In one game, $1, if you throw 1, I just directly pay you $1 and we continue the game. And in another game, I will put $1 into the pot and we continue game. Which game is more favorable to you? Where I pay directly or when I put money into the pot?
When you put to the pot.
No,
Or I gave you just directly?
I think directly is better because there is no chance we will lose this money.
Yeah. If I pay you directly and 6 appears, you have money, the sum in the pot is burned, but you leave with money. And hence, if you just add 1, that perfectly corresponds to the situation when I pay you directly. And if I put money into the pot, you have no 100% guarantee that you will receive this sum. Because if I put money into the pot, then there is a chance that 6 will appear on the dice before 4 and 5, and you will lose. You will not get the money in the pot. That's okay? So I should multiply this dollar by probability of receiving this dollar. And what is the probability of receiving this dollar? We have already calculated it. Somewhere above, we have calculated the probability of getting this sum. That's exactly the probability that the game will end by 4 and 5. If the game ends by 6, we will not get this dollar that I put into the pot. So we should multiply this $1 by which value?
5 of 6.
No, not 5 of 6. Let's go back to the point A.
Just
The game
1 over 3.
Not 1 over 3. 1 over 3 is a bad
Oh, yes, 2
probability.
over 3. 2 over 3.
2 over 3, that's a good probability. Yeah, by 2 over 3. And
because
the
it is
same...
better for us to end the game, yeah?
Yeah.
Just we have 3 cases when our game ends.
Yeah. There
and
are
2 of
only
them
3
are
final cases. Yeah.
when we
The
get.
game ends in the far away future. The game will end. Yeah. We have probability 1 that the game will end. Hence, that's our equation. I hope you can solve it. So you can solve it. The most important point in this exercise is to write this equation. It's easy to solve it. You just replace E of X, E of expected value of X by B, and so that's a linear equation. I hope third-year students can solve linear equations. The most difficult thing is to obtain this equation. So I believe that you can finish the solution and calculate expected value of X. Let's recap quickly what we have done, how we have obtained this equation. Okay, I consider the first principle. I consider only the first step. I do not, the game may have 25 million number of steps, but I consider only the first step. That advantage of the method. The first step may be simple. It may lead to immediate end of the game. So with probability 3 over 6, there is the game ends and I get nothing. But there are 3 complex cases. And in these 3 complex cases, when the dice shows 1, when the dice shows 2, when the dice shows 3. In these 3 cases, I compare the situation after first move with initial situation, and I calculate the difference in my payoff. Let's consider, for example, this block when 1 appears on the dice. When 1 appears on the dice, I have the game that is completely similar to initial with one difference. There is $1 in the pot. This dollar is not mine. It's mine with positive probability, but I may lose it with positive probability. So I multiply 1/6, the probability that the dice will show 1. I multiply it by expected value of x, the expected value in the initial game, plus the advantage, $1 lying in the pot. $1 lying in the pot will be if the game will end by 4 and 5. This dollar will not be mine if the game ends by 6. Hence, I pre-multiply this dollar by 2/3. And hence, that's my advantage over initial situation. Initial situation gives me E of expected value of x, plus this is delta that I have calculated. And by the same manner, I consider the case when the first dice shows 2, when the first dice shows 3. Any questions?
No.
Okay, thank you very much. Once again, I'm terribly sorry for technical difficulties. That happens for me for the first time in 3 years. I have updated the Android on my tab and everything was fine. And now it has removed permissions from Zoom to show the screen, and I can't use my pad for interacting with you. Sorry, but I was not expecting such a problem.
Excuse me, can you send your notes, please, to
Yeah.
Telegram or somewhere?
Yes,
else?
our position that everything is open in our course. So all past exams are available. You can find them on the wiki page. All the
Would be okay.
recordings will be available on the wiki page. This
Okay.
I will make some comments in this file, and I will upload it, and you may find it on the wiki page. Everything will be on the wiki page. So that's our policy, to make everything transparent, and only future exam is hidden. So that's the only thing we hide. All past exams,
Yeah.
everything we have, we will publish.
Actually, feels like Obsidian was a pretty convenient way to view the lecture. Also, I wanted to ask, so we will have another lecture in 23 minutes, right?
Yes, but my lectures, we will not, I will not introduce new objects. I will not introduce new terminology. I just will show you solution techniques. I will show you how to code something. Probably you know Python better than me, but some aspects I will show you. I will show you something you don't know. So my lectures will be practice oriented, and on the 22nd or 23rd, I don't remember the exact date, September, I just replace Piotr, and I will introduce Poisson process. Yes, but normally I'm doing practice sessions, problem session, and Python.
May I have a question?
Yes.
Mhm.
You are free, yeah.
Can we, like the last part of the question, sub-question C, solve the following way? We know that average number of dice
Yes.
rolls 2,
Yes. Yes,
So-
I understand your method. Yes, your method is okay.
Oh,
Yes.
that's great. Thank you.
Yes, obviously. Just my goal was to show you a new technique, but
Mhm.
your approach is also valid. You say the last, you take the average length of the game, you
Mhm.
remove one last move, and you calculate. So basically, you can do so. There another idea. So let me write your idea. Another good idea. Yes, you're right. I've understood what you mean. You say the average n minus. Oh, sorry. Where am I? Okay. You just say this number.
Yeah.
So in the beginning, we are getting money. Yeah, in the beginning, we are getting money, and we multiply. So that's the expected number of cumulative steps.
Mhm.
Yeah, and each cumulative steps gives us 1 plus 2 plus 3 over 3. Yeah, so these
Yeah,
are like
yeah.
cumulative steps,
Mhm.
and you multiply it by you
2 over 3.
multiply it by the probability of
Mhm.
getting this. So you multiply it by 2 over 3.
Mhm.
Yes, I agree with your approach.
Mhm.
Yeah, that's also valid approach. First, you accumulate money in the pot, in the pot, in the pot, in the pot, and
Mhm.
then a lottery with chance 2 over 3. Either you win the pot, either you don't win the pot. Yes.
Mhm. Great. Thank you.
The problem with this, with your technique, may be if you will try to solve point F, the
Mhm.
variation of the game, when for 5 you get money burned and the game restarts.
Mhm.
So your technique will be unavailable. But here, that's a good point. Yes, you can solve it like this. You are completely right. The answer will be the same.
Thank you.
I'm sorry, I didn't understand. Do we have another one lecture right now? No.
Right now, no. Right now, that I just answering your questions.
No, I meant next. На следующей паре у нас сегодня есть лекция еще одна или нет?
No, I think no.
Oh,
Today,
okay,
today, right now.
thank you.
Let me check the let me check the schedule. It should be on
Yeah.
21st to 22nd September, but I'm pretty sure
Okay, I
that I
understand. Yeah.
have written.
Что 22 сентября должно быть только, да?
Yeah, on 21st September, I will, because Piotr is occupied on 23rd September, and we agreed that I will replace the lecture, but no, today we have no. No, I'm right. I have checked the schedule. No.
И ладно, вернусь к вопросу, вот этому 1.2. Не совсем до конца разобралась. Мне проще, наверное, реально на русском спросить более точно.
Yeah, you may.
А вот, ну вот у нас есть, что m от f от t, да? Просто
Да, ее нашли.
почему мы говорим, что m от t равняется ожиданию e в степени n tn? Это потому что мы предполагаем, что здесь экспоненциальное распределение.
Не, это определение, что такое m от t. M от t по определению. By definition. By definition, m of t is just expected value of exponent of tn.
Ну то есть это по определению.
By the definition.
Значит, мне нужно вспомнить.
Мы сами ввели такую функцию. Мы сами ввели это вспомогательный объект, который нужен для вычисления мат ожиданий. И дальше мы говорим, что таких функций есть две. Одна функция, если предположить, что игра начинается из точки f, и вторая такая функция, если предположить, что игра начинается из точки c.
А почему мы знаем, что это... Ладно, а почему мы знаем, что это работает?
Oh, here we are.
Вот это определение, которое мы даем, да.
We know that, потому что мы, то есть, что мы ищем? Мы ищем матождание от n, матождание от n в квадрате, матождание от n в кубе. И мы знаем,
Да.
что производные от этой функции дадут, что нам нужно. Производные искать это такая, ну, может быть, тяжелая, занудная, но не интеллектуальная работа. Вот производную может
Мгм.
найти по-хорошему школьник, да. И поэтому, если мы, то есть у нас есть теория в лекции, которая говорит, если ты нашла эту функцию, из нее ты найдешь любое матожидание, ну, подумаешь, там производные побрать, посидеть. Но брать производные – это не интеллектуальная работа, да? Тут не надо
Да.
ничего придумывать. Поэтому, если мы сможем найти эту функцию, значит, все. Дальше мы можем перепоручить работу 11-класснику и сказать, слушай, найди третью производную, поставь 0, это вот ответ будет. Вот. Поэтому мы ищем эту загадочную функцию. То есть эта функция позволяет нам с помощью взятия производных найти любые матожидания.
Ну вот это да. Но я просто имею в виду, что вот это определение, откуда мы берем.
Оно, почему именно такая функция позволяет?
Ага.
Ну, ну, смотри, давай пока ответ будет, то есть на самом деле тут богатая теория, тут с помощью этой функции можно, мы к этой функции еще вернемся не один раз, пока она будет в формате победителей не судят. Эта функция, если от нее производные брать, позволяет найти матождание?
Мгм.
Позволяет. Ну, значит, найдя ее, значит, она полезный объект. У нее смысл действительно тяжелый немножко. Мы поговорим про ее смысл, но он достаточно тяжелый у функции, производящей моменты. Там, какого-то легкого наглядного смысла не будет. Но, ну, то есть мысль такая, вот сейчас пока на первый раз я бы принял точку зрения, что это очень полезная функция. Из нее находится любое матождание. Хочешь из нее найти матождание от n в пятый? Пожалуйста. Пятую
Мгм.
производную тынь-тынь-тынь-тынь, подставила 0, получила матождание от n в пятый. Поэтому
Ага.
если я найду эту функцию для какой-то случайной величины, неважно для какой, то все, я выиграл. И, соответственно, если ты посмотришь, ну давай сейчас откроем, у меня сейчас шерится окошко, сейчас я его отключу и покажу тебе, например, Википедию, да, вот я возьму сейчас я сделаю Википедия, moment generating function. Сейчас расшарю экран заново, да. Пам-пам-пам. Так, ну что, она открылась? Сейчас надумает. Ну вот я сейчас
Ну,
покажу.
еще вопрос возник, чтобы понять именно, когда ее можно использовать, вот это определение.
Когда надо найти много матожиданий. От n в квадрате, от n в
Мгм.
кубе. Если надо найти матожидание другой степени, да, открылась она. Да, вот я ее открыл. Сейчас я ее тогда покажу, где у меня вики. Вот. Вот.
То есть
Соответственно,
ее можно использовать для нахождения любого вообще ожидания.
да, любого матождания. Матождание от x, матождание от x квадрат, матождание от x кубе. Если просто надо найти только матождание от x, то, наверное, она такая пушка по воробьям. А если
Мгм.
надо найти матождание от x, матождание от x в квадрате, матождание от x в кубе, матождание от x в пятый, то это полезная пушка. Она раз и сразу все найдет. Вот. Ну вот тут вот
Мгм.
определение еще раз, да, что это матождание от экспонента tx. А дальше, ну вот люди посчитали для всех известных случайных величин эту функцию, да, ну там, например, для какого-нибудь вот
А,
она, да, для равномерного, для геометрического, для биномиального, то есть эти функции для известных случайных величин уже посчитаны. И, соответственно, если я хочу найти матожидание от пуассоновской случайной величины в пятой степени, что мне сделать? Я беру эту функцию, она уже посчитана, она уже известна. Беру я пятую производную. А пятую производную на самом деле можно найти тупо, 5 раз взяв производную, а можно найти элегантно разложив в ряд Тейлора, потому что я знаю ряды Тейлора какие-то готовые, и найдя там пятый элемент в ряду Тейлора, да, то есть можно на самом деле быстрее искать пятую производную, чем просто 5 раз штриховать. Вот. Ну, соответственно, если надо найти ожидания от Пуассонской сочетания величины в пятой степени, я беру пятую производную от этой штуки, причем с хитрецой беру по-быстрому, да, подставляю туда 0,
Ага.
и хоп, у меня ожидание от Пуассона в пятой. Надо мне найти ожидания от нормальной сочетания величины в 16 степени. Я беру 16-ю производную, причем 16-ю производную можно найти очень быстро, разложив в ряд Тейлора. Беру, подставляю 0 и получил ожидание от нормальной сочетания величины в 16 степени. Надо мне найти там ожидание от хи квадрата в кубе для какой-то задачи. Я взял третью производную от производящей
А,
функции, подставил туда 0,
так
нашел
это
ожидание.
NGF, получается, у нас была. Ну, то есть moment
Да,
generating function, который мы взяли.
да. Как я говорил,
А почему
тут
именно
moment
вот
generating.
эту именно взяли? Не, я просто не поняла. Это потому, что у нас Пуассонное
А задача
распределение
такая
или...
была. Подожди, задача, которую мы решали, 1-2. Нам надо найти e от n, e от n квадрат, e от n куб. Надо найти 3 зверюк.
Ну да.
Ну, соответственно, проще найти одну функцию и от нее 3 производных. Быстрее.
М, Я просто не понимаю, почему вот эта функция, ну то есть это, я понимаю, что степень, да, значит это какая-то степенная функция должна быть, но почему вот это для Пуассона, которая у нас похожа?
Ну, так это надо доказывать, что для Пуассон такая. То есть, не, это
Не,
я
для
просто привожу...
Пуассона я понимаю, что есть вот такая вещь существует, да, это что это
Мгм,
доказывается.
мгм,
Но я имею в виду,
мгм.
почему мы в этой задаче выбрали вот это. У нас же там не сказано же...
Так мы нашли, какая там производящая функция. Смотри, есть универсальное определение, что такое производящая функция для любой случайной величины. Для любой случайной величины это вот такая штука. Это ожидание
А,
от экспонента t в степени x. Всегда для любой случайной
а,
величины это универсальное определение. Да?
то есть вот это у нас есть, да, вот такое универсальное определение. Из него мы вывели
Нашу
отдельную
конкретную функцию. Нашу
NG, то есть
конкретную.
наш конкретный момент generating function, да?
Да,
Тогда я поняла. Все.
супер, ура, я счастлив.
Не, я
Я
просто
считаю,
поняла
что
вроде
это
тогда, что происходит.
малая педагогическая победа. Спасибо
Эх,
тебе.
я как-то не сразу просто поняла, что здесь идет речь про moment generated function. Как-то.
Ну, может быть, мне стоило еще раз сказать, ну, как бы там в лекциях она была, поэтому я исходил из
Это
того,
да, я
что,
смотрела лекцию, просто как-то что ли еще
ну,
пока не
может быть, мне
запомнила, что
стоило
вот это
повторить
обозначение
определение,
n.
но я просто из-за своего технического косяка съел там время в начале, поэтому вот. Ладно, я добью Zoom, почему он перестал ширить
Мгм.
экран. Ладно,
Получается,
если все
да.
понятно.
То есть мы берем, да. Мгм.
Мгм. Мы взяли универсальное определение функции производящие моменты, применили его к нашей задаче, получили нашу конкретную функцию производящие моменты, от нее взяли 3 производных, ну не взяли, поленились, да, ну как бы могли бы взять 3
Ага.
производных и получить 3 разных ожидания от n в кубе, от n в квадрате.
А вообще тогда интересно, это же мы, когда один move to f, мы же берем e в степени t, то есть это же у нас, по идее же мы взяли мат ожидания
Мгм.
уже от
Мгм.
e в степени умноженное на одну, да? Когда
Да.
мы писали один move to f.
Мгм.
Мгм. И получается, что хотя e в степени... ну да. И таким образом мы получили... А one move to c мы уже писали, что там t умноженное
Выразили
на n
через саму
плюс
себя.
1.
Да.
Мгм. Ну то есть, потому что, чтобы сделать, когда мы делаем шаг к f, то мы, получается, делаем его один раз только, поэтому у нас сразу t.
Да. А если мы
А,
возвращаемся в C, то мы один шаг потратили и заново n, случайное количество впереди перед нами.
ну то есть там получается n плюс 1 у нас.
Да, да. n превратилось в n плюс 1. Нельзя сказать, что n равно n плюс 1. Это было бы ересью, да, с математической точки
Да,
зрения. но оно превратилось в n плюс 1, потому что игра изменилась. В новой игре все такое же, как и раньше, но на ход больше уже потрачено. Поэтому в новой игре вместо n стоит n плюс 1.
Я,
Один был в
получается,
прошлом,
поняла.
еще...
То есть мы говорим о том, что если что вот это m от c, оно у нас... То есть чему равняется один каждый следующий шаг, да? То есть это у нас там вероятность, умноженная на вероятность того, что это конец, да, на мат ожидания, плюс
Да.
на то, что получается
Попадем в
вероятность того,
исходную
что это
ситуацию.
tail, да, и что это уже на 1 плюс ход станет больше.
Да.
Окей. А если мы так захотим для следующего, ну там, например, чтобы появился n плюс 2, то есть...
Можно, просто уравнение будет сложнее. Можно, в принципе, сделать и 2 шага вперед. Но зачем? То есть то, что ты предлагаешь продлить на 2 шага вперед метод, ты получишь корректное уравнение, у которого будет тот же самый корень, ну или какие-то лишние появятся, там могут лишние появиться. Но в том-то и достоинство метода первого шага, что мы дальше одного шага не смотрим. Мы заметили, что ситуация
ну
после
да.
первого шага будет похожа на исходную. А для исходной мы уже знаем, что то, что мы ищем, мы обозначили там, ну, в общем, n уже обозначено. Ну, то есть можно, конечно,
Да.
на 2 шага вперед посмотреть развитие ситуации. Но вся идея метода в том, что мы делаем один шаг. Если игра закончилась, супер. Если игра не закончилась, то мы пытаемся понять, чем отличается новая игра после одного шага от исходной игры.
Все. Да, я поняла откуда. Все. Вот теперь точно.
Вот. Можно сделать метод 2 шагов, получить уравнение, будет более длинное уравнение, но корень нас будет интересовать там тот же самый, поэтому метод одного шага более прикольный.
Ну да, просто что я не сразу, я, так скажем, смотрю, что там n плюс 1, и я поняла, здесь тогда идет речь про то, что мы поменяем вот этот метод, да, одного шага. Ну все, на этом все.
Хорошо. Все, тогда
Я
хорошего
очень
вечера.
слишком долго по таким
Не, я не
маленьким
переживаю. Я
вопросам.
считаю, что на самом деле современное образование, ну, мы все материалы публикуем открыто, и поэтому на самом деле, ну, как-то идеальный, наверное, семинар будущего, что материалов полно, все есть, и, собственно, все занятия состоят в ответах на вопросы, потому что ты сам можешь на YouTube посмотреть, там, попросить чат GPT что-то тебе рассказать, и тебе живой человек по-хорошему, наверное, будет нужен только когда у тебя есть вопрос. Поэтому, на самом деле, я считаю, что, ну, не, мы, конечно, все выкладываем, но, на мой взгляд, от вопросов больше пользы, чем ну, в общем, короче говоря, я очень ценю вопрос, поэтому я не переживаю на тему. Ладно, тогда тебе хорошего вечера. Вот, давай. Пока-пока.
Да, вот спасибо, что ответили. Все, до свидания.